Samia.
Thank you, Josh. Hello, everyone. Thank you so much for joining us today. I know we have people from all over the world joining us, even places where it's kind of late in the day. So thank you so much for joining us. It's Tuesday, so we are one step closer to Friday than we were yesterday. So my name is Samia Akhtar, and I'm a software engineer at Microsoft. I work on building tools for Azure customers in the GitOps and cloud native space. I'm passionate about open source, GitOps, front-end related projects, which means I'm a huge fan of and user of both Flux and Helm. And I'm super excited for this talk today. So a bit more about our meetup. We are cloud native at scale. We are a San Francisco-based meetup focused on CNCF projects. And if you're interested in joining us, Josh will post a link in the chat shortly. So today we are going to talk about a very exciting topic. Our speakers, who I will introduce shortly, are going to present a feature showcase and demos of both Flux and Helm, the reasons for overwhelming community use of Helm for application packaging and deployment on Kubernetes, and how Helm is extended by Flux for teams moving to GitOps. And our speakers today are Martin Hickey and Scott Rigby. Martin is currently a software engineer at IBM, focusing on cloud native open source software, and he's a regular contributor to open source and core maintainer for Helm. He enjoys speaking at conferences and meetups and getting the chance to discuss topics with people. Martin is going to present a feature showcase on Helm, giving an intro and where it is right now. He's going to talk about projects which leverage Helm through its SDK, tools like Flux's Helm controller, for example. And we're going to be shown what's next for Helm. And as for Scott, I could probably wait to introduce Scott when he gets on, but let me introduce so you're all aware of our two speakers today. Scott is a Brooklyn-based interdisciplinary artist and developer advocate at Weaveworks. He co-founded the Basecamp Art and Research Group in 1998 and the massively collaborative Plausible Art World's International Network. In technology, he develops open source software that anyone can use, and most recently in the cloud native landscape, including co-maintaining Helm and Flux. Scott will give us a very brief intro and update on Flux and introduce the GitOps toolkit, and he will walk us through the Flux controllers. So without any further ado, let's get started. I'm going to hand it over to Martin.
Oh, sure. Real quick, though, can you hear me fine?
Yes, I can.
Yes.
Okay, good.
Awesome. Yay. There we have Scott.
Loud and clear. And everyone, regarding the questions, go ahead and start putting questions in there and we'll start managing that. And Martin.
Welcome to the party, everybody. Let me just get my deck up here and running.
Yeah.
1 second. Okay, can you see my deck?
Yes, we can.
Yes.
And am I in the proper mode?
You are.
Yes.
Oh, fantastic. I love when technology decides to work for you, then against you. Poor Scott, I think, was having technology working against him, but he's here and he's here at the party. So welcome, everybody. Thank you to all the organizers for bringing me here today. Samia, Josh, and Stacy, and also for Scott for asking me to come on board on this. I'm going to talk today about Helm. I'm going to give an overview of Helm. I'm going to see how it works and just say where's Helm at this moment and where we're going forward. So it's more an introduction, and I'll talk through it. There's lots of stuff where you can deep dive into it even more or come out into the community. I don't think I could have done a better intro than Samia did about me. Generally, I struggle to talk about myself, but in a nutshell, as Samia said, I'm a developer. I work over at IBM, and I've worked in open source for the last number of years. And yeah, I'm a Helm maintainer. So yeah, I work in the community with Scott and with other great folks out there. So we're gonna, let's just jump through the contents and we get into it, I think. So I suppose, what is Helm? What are we going to talk about Helm today? Where does it fit in with in the Kubernetes ecosystem? And also we want to see what kind of details does it bring. So just 1 second, I just have a problem. Aha, that's much better now to see. So I put two definitions up here from the Helm community page website. And when I look at these, what I think of when I distill them down is two things stand out for me is that first of all, Helm simplifies your management of Kubernetes apps. It manages that lifecycle when you're deploying your apps into Kubernetes, when you're doing your creates, your updates, deletes, etc. And then additionally, what it gives you is it gives you this ability to share something we'll talk about in a while around charts, which gives you this ability where when somebody creates a chart which allows you to deploy your app, it can be used by other people. So you can consume it without having to know everything, the intricacies of the inside of the chart, and but you can still use it to deploy your app out into the cluster. You've probably heard the phrase, if you've heard about Helm before, is that it's the package manager for Kubernetes. And this is a nice way of describing it. And you can see in your mind's eye here as if you've heard of apt and yum before. It's really a tool, like these tools like apt and yum provide you with tools to deploy apps and programs out into Linux. And it's the same with Helm. It allows you to deploy your apps into Kubernetes. I think my button just stopped working. Aha, here we go. So rather than go through a series of monotonous slides of it does this, it does that, it does the other thing, I've decided to look at an example and how that example of some e-commerce app that how you deploy it using Kubernetes and then how you deploy it using Helm. Now, what I'm going to do is I'm going to borrow from a really nice 5-minute video on what is Helm by a person called David Oken. You can see the link in the bottom right-hand corner. And David picked a really novel idea. Now, I don't have the flashy little clear screens and I can have the markers drawn. But what I'm going to do is I'm going to take his idea, which is a really nice idea about this app where shoppers can sign up onto this platform. And when it is during the holidays, he increases the replica sets or the amount of instances running to take the traffic. Now, it's going to be slightly different to how he did it because also he used Helm 2, and there are some differences between Helm 2 and Helm 3. But I think it's a nice way to show where Helm fits in the Kubernetes ecosystem. So this shopping app is a Node.js app that's going to be deployed into the cluster. It's going to have a backend database, a MongoDB, for persisting all the data. And then if you have knowledge of Kubernetes, to be able to access these instances that are running, because they're running inside in pods, you need a service, because a service provides you a way of mapping the internal IPs out to an external IP for you or DNS URL so you can access it. So if we're going to do this with Kubernetes, there's many ways to deploy this, but we look at the standard way that most people use, and that's the manifest files. And in these manifest files, we declare to Kubernetes what we want deployed. In this situation, we want a deployment object and we want a service object. Now, I've stripped out most of the information out of the manifest, and I just want to look at 2 bits in each one. So the first one is, the key bits here is like, what image are we going to use? So this is our e-commerce app image. It's a Node image and the version of it. And then we're going to say, because it's a holiday period, we're going to have 2 instances running to load balance the traffic that's coming in. Our service object, I'm going to use a simple Node.js because it's just an example we're using here. Obviously, if you were doing in a production, etc., you would use other types of service objects, and I'm just going to use a simple port of 8080. Now, when we want to deploy this with Kubernetes, we're going to use the tried and trusted CLI kubectl, and we're going to just do apply to the directory where our files are in. And you can see in this that it's just basically going to call the Kubernetes API server, and it does the magic afterwards, deploys everything out, and we're up and running. Here, presto. Now, one thing with this is when you create this, these manifest files, you know exactly where the configuration is. If you want to change, for example, if you want to change the service object you want to use to a load balancer, if you want to change it, the number of replicas you want to run, your instances of the node, etc. If you update your app, then you know exactly where everything is. And this is also a really simple example. But what happens if your application becomes more complicated? What happens if it becomes a much bigger application with a lot of resources? Maybe you'll also tie in your database. So all of a sudden you've gone from maybe 2 manifest files to maybe 10, 15, 10, 20 or 30. And all of a sudden then it becomes a little bit more difficult to manage it. But also too, if you need to hand this over to someone and they need to be able to deploy it and make changes and stuff and go into the manifest files, it's going to be far more difficult to manage.
And Martin, because of the way Kubernetes works, right, you're necessarily almost always going to have repeating values throughout these different manifests so that they can connect together, right, through labels, annotations, ports, etc.
Yeah, totally, Scott. That's a really good point. So what you're always going to be looking at is you're always going to be changing something for your environment, or if you want to run more than one instance of this. You need to have the ability to change it so there aren't conflicts or issues in it. So these changes, as Scott says, are really important. So wouldn't it be really nice if we could take this configuration out of the manifest files to someplace more central or easier to make the changes in, so that if you have to hand it over to your friend in the office and you're leaving the office or you're going away somewhere, they'll find it a lot more easier to manage. Do we have that today? Yes, we have with Helm. So let's look at now deploying this app again using Helm this time. So you can see here now on the left-hand side, we've had a few changes. The first one standing out is we now have a values file. And in this values file, we have taken those configuration items and we've put them in here. Now, this is obviously a stripped down and simplified version of the values file, where for this example, it'll do it to show it this way. Now you can see here, if we look at our 2 manifest files, they've slightly changed. And you can see here, there's no kind of funny nomenclature in here, using curly braces and using the dot values and the dep image. And what these are is, what Helm provides you with is a very templating language, Go templating language, on top of the manifest files. So what it means is you can provide logic and ability to reference configuration variables on the fly when you're deploying your app into the cluster. So you can see now for someone that wants to use it, they now know where the values are and where can they set those values to make the changes. Also, another part of Helm is it provides you with the capability of a thing called charts. And charts is a packaging format. And this packaging format allows you to put your collection of files, your manifest files or your template files in this situation that are related to all these Kubernetes resources that you need to deploy for your application into one location, into a chart. So it makes it a lot easier for somebody to use or reuse, because now you have the ability, when you're deploying, you can make the changes while you're doing the deployment. So if we go now to deploy using Helm, we can see this time we're going to use the Helm Install command, and we're going to use the name of our chart. Let's call it my chart in this situation. The instance of our application we're going to deploy, we're going to call it my app. So when Helm calls this, it's going to take these template files, which are essentially Kubernetes manifest files with some templating on top, and it'll take the set of values that are set in the values file, or you can also set them in the CLI on the fly as well, and it'll render them into manifest files, inserting all the values and any logic that's there, and then it passes the manifest files to Kubernetes API server, similar to kubectl. And the magic happens again. Now, one existing thing that Helm does on top of this as well is it now stores this metadata around this chart that you rendered in the cluster. So what this means, as I mentioned earlier, was around this idea of the life cycles, that you now have the idea of a life cycle of your app. So you know when you do an install of the app, and then you can maybe upgrade the app. And then if something is wrong with the app, you can roll back to a version. You're now storing this metadata, and that's how Helm allows you to have a life cycle around the app. It also means, and we'll see in a minute, if you want to change the replica, how you can do that. So in that situation, let's say now we finished with the holiday period. We don't need more than 2 instances. Probably you're going to have way more than 2, but let's say we go now from 2 back to 1. What this means then is making our change in our values file, or we can set it on the CLI and we do an upgrade. So when we do an upgrade, it's saying, okay, there's an instance of my application called my app deployed in the cluster. I now want to update this. And how you're updating it is you're changing the replica. It's going to render the manifest again. It's going to find the previous information in it to look for any deltas. And then it's going to pass that information to Kubernetes API server. And then it's going to then store the new metadata that has arisen from the upgrade. And what happens then is then Kubernetes declaratively goes away and changes the amount of replicas. So you can see here that. Yeah,
sorry to interrupt. Quick question here. Just to confirm, so if you mentioned that the Helm CLI allows you to pass in these values in as part of the command itself. So would this be a very useful tool if someone was to put this inside of a pipeline and have that run as part of their deployment, and that would be the same behavior as updating the values file, correct?
Yes, totally. And that happens with some of the tools that are out there. And we'll talk about it in a little while, where some of the projects out there, they build on top of Helm using its SDK, and they basically create their own clients.
Okay, thank you.
Okay, and Samia, keep coming with the questions, and anyone else, if you have them, I don't mind stopping as I go along.
Yeah, hold on real quick, Martin. So Sanjeev, you have your hand up there. If you don't mind, can you put your question in the Q&A box? Did I scare him? He disappeared.
Okay, Sanjeev, if you're still on, yeah, just put it in there, and yeah, I can field it as we go along, and I'll do my best to answer that. Okay, so thanks for that. So yeah, so as I said earlier here, with this ability now, you have the ability to roll back as well if you end up having an issue or it's not something you want to deploy. So for example, maybe you deployed version 2.1 of your app and you found a bug in it. So in the meantime, you want to roll back to version 2 till you come out with a new version. You can do you have the rollback command that allows you to do this. And this is all because the metadata between the different installs and upgrades, etc., is stored in the cluster. So one of the last aspects I want to touch around Helm in this scenario is what I mentioned earlier, coming from the definitions at the start of the talk, is the idea here of being able to share, being able to reuse. So this comes from, first of all, having the package and format chart, and then having an ability to store it in distributed systems called repos, which are really just HTTP servers that is an index of what is stored, and then basically you can reference it. And how you reference it is you can add these repos, which are the URLs, into Helm. So when Helm's doing an install, you can then reference it. You might put an alias for the repo. You might call it my repo, and it'll have the URL, and it'll know that my repo is an alias for the particular URL. So when it's doing the install, then it knows then that it can install from that repo. So there's a lot of really good repos out there. Bitnami is one of them, to name one. There's ones from many different companies, Microsoft, IBM, etc. So in all these different repos, they've got versions of their charts that you can use and reuse. For example, MySQL, Nginx, WordPress, whatever you're looking for, there's generally a chart out there to deploy. So one little point to add as well, that something we've added in Helm 3, it's still in experimental, is the ability to store charts in OCI image registries, exactly like where you store your container image, for example, like Docker Hub or whatever, or Quay or whatever image registry you use. So that capability is now in Helm, but as I say, it's in experimental mode. So just be aware that things may change until it becomes fully supported. So just conclude on what we've talked here about using this example is that first of all, we looked at it when we used Kubernetes manifest files and we were using hard-coded values. And then we looked a way to parameterize that or pull out that configuration, making it easier to make changes. And then finally, we finished up here with the ability of sharing apps and stuff like this. And what's nice about the charts and the repos, it means is if you just want to deploy the app, you don't need to understand the whole creation behind the chart or the logic that's within the chart. Also, we found too as well that there are certain people that start using Helm and they use it to get an understanding of Kubernetes. So that sounds strange because you think it would be the other way around. You know, people know Kubernetes, they want to create their apps, etc., like that, or deploy their apps. But also for some people, it is a nice low barrier of entry into Kubernetes because it gives you an ability to take an app and deploy it and see what are the different resources that are deployed in the cluster. Okay, so now previously I talked about what Helm is, and now I'm going to flip it on its head and say what Helm is not. So let's have a look at that, because I think this is going to be important because sometimes issues come up in the Helm community and people say, well, I've used it doing this and you know, Helm didn't do what it's supposed to do and it worked in a certain way. And why I want to look at this is that there's certain parts that Helm is designed for and certain bits are not, even though you can use it for that, if that makes sense. How's things going out there, folks? Samia and Josh and Stacey?
I think it's going pretty well. Scott, you've answered a couple questions. Does it make sense to bring it up to everyone, or?
Sure. Yeah. Yeah. I was just going to say, Martin, things are sounding great for me. As I mean, I'm one of the panelists, but I'm also an audience member at this point. So it's just interesting as hell. And here are the questions so far, just so you know. There was really the one that was described. There was one question about Flux that I just essentially said, I'll describe that and just, you know, please interact as I go with more detailed questions about it. There was also a question about Helm and OCI. You know, essentially plans for you know, moving OCI beyond experimental in Helm and then to the point where it can be ingested by other tools like Flux through the SDK. And I think the only other—
Can I cover that one actually, Scott?
You definitely can, please. And I just to cap it, there was one other that was simply just a follow-up, basically plus oneing that. So
lovely. Yeah. I'm just going to say one or two things on the OCI. So yes, it is experimental. Yes, it has been experimental for, Scott, keep me honest here, maybe a year or two at this stage, because it came in with Helm 3.
I'll have to look at the date, but yeah, basically.
1 second, I just need. Excuse me, I just needed a cough there. It's experimental because it's involved with a lot of different groups. And what I mean by that is there's been a lot of work going on with the OCI community, the Open Container Initiative community, and coming up with the standard for this, okay? So the standard for containers came from Docker, and Docker very kindly decided to bring that standard out into the community, into an open source community called the OCI. So there's a lot of people working on this. Josh Strelinsky has done a lot of work on this from the Helm community, and he's been working with the OCI to come up with a standard. And I think the first version of that standard came out, and it's now trying to update things within Helm. Now, you know, one of the things that have come up is that people saw this OCI capability as, you know, fully supported and started using it in production in different places, and changes have been made, and it has broken things because in experimental, do not expect things to work from one release to the other until it's fully supported. So there are a bit of work going around that, and I would hope over the next couple of months that it will go to full support, but please don't hold me on that because it's not something I'm fully involved with, but I know there are a lot of good people working hard on this. Okay, so
Actually, sorry, Martin, to interrupt. There's one more question that I think would be good to address here.
you sure?
So Venkat is asking, what about the security aspect, as it may go around Kubernetes authorization and RBAC concepts, as Helm itself does not have any concept of authorization?
Okay, very good question, actually. So sorry, who's the person who raised it to me?
Venkat?
Sorry, I missed that.
Venkat.
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 Venkat. Okay, hopefully I'm not destroying your name, Venkat. I apologize in advance if I am. That's a really good question, because there's a big difference here, and I'm not going to go into it too much, but there was a Helm 2 release and there's a Helm 3 release. Helm 3 was released in, I would say, October, November 2019, about 2 years ago. And there was a big architectural change from 2 to 3. So in Helm 2, we had a server that was sitting inside in the cluster called Tiller. We communicated to Tiller, and then Tiller communicated to the Kubernetes API server. In Helm 3, we removed Tiller, the middleman, and we basically talk directly now to Kubernetes API server like kubectl. When Helm 2 first came out, RBAC wasn't there, or he was at his infancy. And now with Helm 3, we were able to work straight with RBAC. So every RBAC capability you have with kubectl, you now have it with Helm, because Helm and kubectl work the same way around kube configuration files. Okay, is that it? Or will I move on, or any other questions?
There's a couple of questions in the Q&A box. Would it be best to address this now, or should we keep that for after?
Look, let me move on a bit, because I know
Okay.
Scott has to talk as well, and
Yes, let's go ahead.
I'm cognizant of the fact that I don't want to squeeze him into 30 seconds, and he'll never get through his deck. So yeah. Okay, let's move on, but we'll hit him again, Samia, if we have time, or at the very end then if we have time. But yeah, let's go to it. Okay, so all right, my button not working again. Okay, sorry about this, folks. This is technology. Here we go. So what Helm is not. So why have I put this up here? I've put this up here because everything you see on this list, people tend to try and use Helm for as well. Now you can use it for, but it was not designed for this. And you may hit boundaries or edge cases that we just don't support. And they often come up in our issue queue, and we explain it's not for that. And people, sometimes people don't understand why. But we try and explain as best we can. So around configuration management is, we have a way to add your configuration, but not for handling multiple configuration files. And what I mean by that is, if you have a configuration file for your dev, for your production, for your test or whatever, we don't have any nice way of managing them. There are very good tools out there, much better tools out there for this, like Helm File, Flux, and Drone, etc., that are built on top of Helm that's specific for these purposes, especially around Helm File as well, because the way it stores the different versions of your configuration file. Around cluster configuration, whether you want to call it cloud or cluster configuration or automation, the same thing here again. There's been we've seen some amazing stuff done by people setting up clouds, etc., using Helm. Again, it's not designed for that. It's for deploying your apps into the cluster. Even a colleague of mine, Taylor, we did a talk at config management camp in 2020 in Belgium, and he did a kind of a nerdy thing halfway through the talk around, here's some things he did with configuration of cluster using Helm files. Again, there's better tools out there like Airship to do this.
Martin, can I just jump in real quick?
Yeah.
Just to interrupt you and keep you on your toes for fun. There was a question that you were just, I think, coincidentally answering right as it was asked, and I wanted to just wanted to embellish on it slightly. So Ezekiel asks, Helm value/answers management, specifically when you have a base plus environment overrides. Is there a proposal to solve this using Helm? Said env substitution. And my question is, when you need to update multiple annotations, not a single value, do you want to take that, or do you want me to just like tack on to what you were saying?
Tack on to it, I'd say. Yeah.
Okay. Yeah. So the short answer is that Helm solved this a long time ago through using Go templating. So I know Martin mentioned it before, but just in case it wasn't clear, I think he's going to get into more of it too. But like, just in case it wasn't really clear, the values file for the values file that comes with a chart holds the default values for a chart, but you can also point to additional values files. Martin was just saying, let's say one for prod, one for dev, one for etc. Those are not, that functionality to manage all of those environments isn't built into Helm, but the ability to specify which files you want to use for your values is built into Helm. That's like at least the CLI command. Well, I mean, Helm is the CLI command, but using the set, using the value, the dash values parameter, or otherwise it's the -f for short for files, I guess the values files, or so you can do that. So you can set a number of different files, and they will the values will coalesce and merge and ultimately do a deep merge together. And you can also use --set to override specific values on the command line. This is what a lot of people do in CI, for example, when they have their own environment variable called environment or something, and then they have a file called values-environment.yaml. You know, and they'll use that as part of their own, you know, scripting logic to override those values on a per environment basis.
Yeah, very good response on that. And
yeah,
just like what I'd add to that, what Scott said there was, Helm provides you the ability to pass those configuration files, and you can even chain more than one configuration file, and one will override the other that's in front. But the point he's making is there is not management for that. There is an inability to set environment variables that comes up a lot. And this is where your configuration management tools like Flux and Helm file really come to play. And we always recommend to certain things that don't go into core, you know, build on top of Helm for that. Getting back to the cluster resource management, yeah, this is another one where really the key here is, and if we look at CRDs, for example, on this, is for Helm, there's no sure way of knowing sometimes the effect of what a CRD will do. Now, we stripped it back in Helm 3 where you can now install a CRD, but there's no updates or deletes provided anymore. And the reason behind that is, as we said, is if you have a CRD and there's multiple CR instances for that CRD out there, and it might be for, you know, app A, app B, app C. If app C had the ability to delete the CRD, then that's going to pull the rug under app A and app B, even though it doesn't mean to do that. And there's no way for Helm to tell what the side effect of that is through Kubernetes at the moment. And that's one of the reasons why why the project steers clear of cluster resource management. The last one then is day 2 ops, which really are, you know, is when the operations that happen after your basic installations or updates, etc. And it's things where when you're doing, like, I don't know, backups or syncing of caches or schema updates, or all these types of things that are really specific to your application that's normally done by a human operator. And it's something that Kubernetes can't handle itself, and it needs to be baked in by the human operator. The tools probably out there at the moment, or the technologies, is probably operators is your way of coding this. Okay, so here's just, I want to give you a little flavor of some of the projects that are building on top of Helm. Like I said earlier, when we look at the things it does not, these are why some of these tools have extended Helm and bring real value to the space that's needed. So first, top left, I have Flux here. You're in the GitOps CI/CD space. I'm not going to talk too much on this, and I'll be handing it over to Scott that'll be able to enrich you and inform you a lot better. Just to the right of it then, with the round circle and the lightning symbol, is the operator SDK. And this is a tool for creating operators. It allows you to create Helm Ansible and Go operators, and it simplifies the ability to do that. And also around Helm, it provides you that capability, and Flux does it as well, is that the Flux operator is that when if the state of the cluster is out of sync with the manifest files in Helm, it will update them, and also on rollbacks as well. If rollbacks or upgrades can't happen, it'll go back into the state that it was in. Helm file to the right of this, I've just shown the repo here. I don't have a symbol. Helm file, as I said, is for your configuration manager and CI/CD, and a great way of managing your configuration files for your different environments. To the bottom left is Airship, and this is for automating cloud provisioning or configuration, and this is for OpenStack and Kubernetes. And finally, down the bottom right is Drone, which is a CI platform. So check these out, please, and there's a lot more that's doing it. How they're interfacing to Helm is through the Helm SDK or library, and that has improved quite a bit in Helm 3, and we'll be looking again to improve it in Helm 4. Right. That brings us on nicely to where we know with Helm and what's up next. And again, every time I click a button, it goes on me. So, oh, I jumped, I'd say. Yeah, sorry about that. Okay, we're back here. So where is Helm now? So I'm going to keep this really simple message, actually, because there's a lot of people that have been using Helm 2, and they're still out there, and that's great. But please get off Helm 2 as soon as possible. There's a tool there for you to migrate, and the reason is Helm 2 has not been supported since November 2020, so that's going on a year. So please do that. The information's there on the tool, and also there's a really nice workshop we did last October.
Can you put those, Martin, can you put those links in the chat maybe?
I can indeed at the end, yeah, or I can make the deck available as well if you want.
Yeah, we'll send the deck out. Thanks.
As a PDF, yeah. Where yeah. I'll give those links out because they're like, I don't really want to go into the migration because it's a talk on its own.
Sure.
So yeah, okay. So a little bits of trivia for you. We've had 13 releases in the last year. There was 5 million downloads of Helm in August alone. And as I said earlier, we have no support for the OCI registry, even though it's still experimental. So where are we going next with Helm? Helm 4. The kickoff talks are going to start starting this month between the maintainers to see where we're going to go, how it's going to work, etc. We're hoping for an 18-month cycle for the first RC. And if you have any features, please get them in now. Is a good time. You'll need to draft the HIP, which is equivalent to the KEP in Kubernetes. One of the features I mentioned there is the Sdk Improvements, what I talk about. And this has come from all the great projects out there that are clients to Helm, that are using Helm. For example, Flux, the operator, SDK, Helm file, etc. They've been just providing support back to us or information back to us and telling us, look, you know, the SDK is working great here. It's not working so great here. So we'll be trying to add more improvements and to simplify it even a bit more. But definitely there's a great improvement from Helm 2. Right, there's a few links on Helm. You get way more out on the internet. So just go out there and have a look. And yeah, I'm going to go on now quickly. I'm nearly finishing up and talk about how to quickly get started with Helm. How are we on time, folks?
I think
You're looking good.
Yeah. Thanks.
Okay. All right. I don't want to use up all the oxygen, so sorry if I've been. I could talk for years on this, but there we go. So I just want to give you a quick overview of getting started on Helm. Okay, I've done a kind of I don't know, we call it binary tree or something here. But look, when you're starting off, I always find for me is being able to jump in the background is very useful. For example, having a look at the docs, having a look at any issues, PRs out there, and look, you're committing to nothing. Then you can be reading in the background, building up your knowledge in it. Also, we've good communication channels in the community. We have Slack, where we have a couple of channels. Helm Users is your more general one. Helm Dev or Charts if you want to be around development and charts. But Helm Users to start with is good. We have a weekly meeting every Thursday from 9:30 to 10 on Pacific time. Hope I got that time zone right, folks. I'm always a bit confused on the on some of the time zones. And there's a mailing list out there as well. You can check out things, and there's a Twitter account called Helm Pack. So I just advise you, yeah, just get in there, see what's happening, even ask questions in Slack. And if you don't, just see what's going on, because it's a good way of picking up stuff. And the documentation has been really improved as we've gone along. And if you find anything as you're looking at the docs, that's a great way to make a contribution if you want to make one. We always love to see contributions on docs because it helps folks starting, it helps folks using, consuming in the product. Right, if you want to set a dev environment up quickly, your prereqs are, it's a Go project, so you're going to need Go if you're building it. Git is always helpful because you might want to clone down the repo, which is the Helm repo in the Helm org. So it's Helm, like Kubernetes. You will also need a Kubernetes cluster because your goal at the end of the day is to be able to deploy your apps into the cluster. So if you don't have one, then you're going to need it. It works well with Minikube, Kind, any of the public clouds out there or the public clusters out there. Yeah, just go for it. And then kubectl obviously for doing for checking stuff in your cluster and talking to your cluster. If you because it's a Go project, we make files, so make the build it, make test the test. When you do a build, it'll be built in. It will be built in the bin directory of the project. Getting going, we have a nice way of creating a simple and Nginx chart that you can deploy into your cluster. So check that out with the Helm create command. You give it the name of the chart you want to call it. Helm Install then, as I showed earlier, for installing. And if you want to debug, nice ways to debug it is, as I mentioned earlier, it's a templated language built on top of the manifest. So that templated language gets rendered using the configuration values. And if you want to see what it is before it deploys into the cluster, or if you're having an error, a nice way to use is Helm Template, which just renders all the manifest out into standard out, or you can put it into a directory. And then also you can use with Helm Install, if you use --debug and --try run flags, then what it'll do is it won't deploy to the cluster, but it'll render everything out for you as if it's going to before it installs it in. So it's a nice way of checking what's going on. And then also when you want to look at your different deployments, you can use Helm list, which is Helm list. So I think that's about it for me. Right. Any questions, or do you want to go straight over to Scott, folks?
How about this? We can ask questions. Why don't I go ahead and we can ask questions throughout? I had Samia was just asking, how should we do the transition? Because it is your job, Samia. I'm happy to do it, but I also had a transition question. So however we want to work that out, we can totally have fun.
Yeah, for sure. So thank you so much, Martin. This was a very, very useful, I learned a lot from your session. So thank you so much. And now that we are almost at the 30-minute mark, I want to switch it over to Scott. And I want to see, I'm really curious about, what Scott has to show us today. So yes, please dive right in and let us know what your transition thoughts are.
Yeah, for sure. So my transition question, or our transition question we planned, was this one. It's kind of a funny one. It's, so Martin, why do you think people use Helm so much? You still have that one on your mind? Do you have thoughts on that?
Apologies, I was drinking water.
How dare you?
I have a slight bit of a cold at the moment, so a few times I've had to kind of just swing to the side. So why do you think Helm is so popular? Okay, that's a nice question, actually. I love this when I work with you or Taylor. You never tell me these questions in advance. You just kind of put it out there and, oh, yeah, just answer that there, yeah. Okay. I think, in my own opinion, and from talking to people at the booth at the CNCF conferences, the Helm booth at the CNCF conferences, and folks, if you are going to KubeCon or you're doing KubeCon virtually, please come to the Helm booth. We both have a virtual booth and we have a physical booth. I know Scott's going to be at the physical. I'll be at the virtual on next Friday. I hope I have this right, because I'll tell people there's a virtual booth and there'll be none, but there we go. So for me, there's two people. Number one, I think I mentioned the first person first, which I think surprises a lot of people is you want to come out and you want to check out Kubernetes. And let's be fair, Kubernetes is complicated. There's no two ways around that. There's a lot of moving parts. If you're not a hardcore sysadmin, it definitely makes it even more difficult. And what Helm gives you, it gives you that abstraction level. As I said earlier, you can go Helm create, and you can create the scaffold chart, which is an Nginx server, and you can deploy it into the cluster. So with two commands, well, bring down your Helm binary, Helm create, Helm install, suddenly you'll have deployed a series of Kubernetes resources into your Kubernetes cluster. I don't think there's any easier way to do that. And what you can do then is you can go in and check out these resources that are there and what happened there. Okay, so it does give you that level. For the other people then is you have your chart maintainers or your chart creators. People like Scott has done a lot of work in this area, and other people out in the community has done this, Matt Farina, etc., where they've maintained charts over a period of time or created charts. And what these are is this gives you the ability to deploy apps into Kubernetes without knowing anything about Kubernetes again. Okay, so these different people have created these charts, be it WordPress, be it MySQL, be it, I don't know, Redis, whatever you want into the cluster. It gives you that capability. We now see with operators as well, it's used to deploy operators into the cluster if you want. So again, they're the people who create. And then finally, they're the people who consume in a regular basis. So first of all, I mentioned the people who are just trying things out, and then the people who are, their livelihoods depend on it, where basically, you know, they deploy these apps in so they can use them. They're either building up on the apps or whatever else. And they're the consumers of commercial apps that are out there or your open source apps that are available. So I think there's about 3 people in that. Does that kind of cover it, Scott?
Yeah, Martin, I think you were pretty close. You get partial credit for that. Yeah, that's actually exactly what I want to hear. But we also do have a user roles document in the community docs, but like really what Martin said is like what actually matters to almost like 99% of the people. So that is perfect. Yeah, and basically, yes, I am actually going to tell you real things, everyone, too, about Flux. There's just, I wanted to ask you all if you do feel like interacting in the chat, just if you want to tell us what you think, you know, why either you use Helm, why you think people, you know, really use it. And I'll just tell you two quick warnings. One is you lose points if your only comment is Helm sucks because I hate YAML. So, okay, so that's fine. We're going to remove that in Helm 3, but it was kept by popular demand. So you get to complain to everyone else in the community about that one, but I still want to hear what you have to say. And then you gain points, believe it or not, by complaining about Helm's limited CRD support, because like Martin said, this is by design, and there are very good reasons for that have to do with Helm scope, and I'll cover them a little bit more when I talk about the scope where Flux picks up on that and takes it.
Very exciting. So everyone, please be sure to use the Q&A box. And I know that Mark has a question. Mark, please, if you could put your question into the Q&A box. So we would love to answer it. And I'm very excited to see, you know, what thoughts people have for why we use Helm. This is really, really exciting. I personally use Helm because I love templatizing things and not having to, you know, deal with. But yeah, that's a very, very simple reason why I use Helm. Back to you, Scott.
Samia, I love that answer, and I love Ian's answer so far. Wow. Okay. Cool. All right. So I should share my screen now, right? Let's see here.
Yes, go ahead.
Okay.
That's okay, Scott. If you just want to talk away ad lib, I'm okay with it.
No, I've decided not. I gave myself a little leeway for that in the beginning with you, Martin, just because, you know, that's part of our tit for tat. But here is the slides. Can you all see this okay?
You're on.
Yes.
Yeah, I think, yeah.
Yep, you can see.
Yeah, you can see my slide that says who I am and that there's a Helm and Flux feature showcase. Okay.
Yeah, it's perfect.
All right, perfect. Okay, so I am obligated to promote, not only obligated, I'm actually excited about this, to promote this. Not only is GitOpsCon coming up, which I hope you all are registered for and joining, if not in person, then remotely. If you don't know anything about this, then I should have put a slide saying GitOpsCon. Basically, it's part of KubeCon, and please go in there and register, because there's just going to be so many awesome talks about GitOps in general, of which Flux is one of the main tools for. Then there's this GitOps one-stop shop event that just like, please go to that. This is just like a 2-second plug. Basically, this is not for Weaveworks primarily, although Weaveworks is one of the vendors. It's really like communities across, or excuse me, big companies across the board. In fact, I think Weaveworks is the smallest by far company here. There's AWS, D2IQ, Microsoft, VMware, and others who have built their GitOps offerings on top of Flux. So that's part of also the why should I care about what you have to say? Well, these people do, so maybe you might want to too. And then just, we'll give these slides at the end, so I won't spend too much time on this, because I think this is probably our third talk to this audience, most of the people in this audience in Josh's group, about Flux, but just getting started, becoming part of the community, etc. Please join us, and we'll post this slide again. So in short, I'm going to just fly over the GitOps for like maybe the 3 or 4 people that this may be your first one, and I won't bore the rest of you by spending too much time on this. I'm going to get right into kind of picking up where Martin left off with Helm and Flux's Helm integration. But in short, GitOps it's an application. Basically the basics are, as the name indicates, it's Git plus ops, right? So sometimes we like to say operations by pull request, where you have a Git repo as a single source of truth. But it's not just for application development and not just for operations, but it's really a methodology that crosses all of those areas. So if you hear people talking about GitOpsifying all the things or everything, that there's value like reliability, velocity, security benefits, and so on, that's all true as well. But in short, it's a paradigm and a methodology, not just a single tool or technology, even though I'm going to be focusing on Flux. So really, ultimately, if you're using Kubernetes, GitOps is really part of the evolution of Kubernetes. We leverage Kubernetes API. We use Kubernetes under the hood mostly for reconciliation, because Kubernetes happens to be the best reconciliation tool out there, or reconciliation engine, you could say, out there. But GitOps is not specific even to Kubernetes either. It just happens to really extend where Kubernetes started with declarative API-driven management of resources. So I'm going to move on from this one real quick, and I hope that if that was the first time you heard GitOps, it was slightly comprehensible. But in short, the principles are pretty straightforward. The wording of this is not exact. Right now, I'm also in the GitOps working group, and one of the chairs, and in the Open GitOps project, where these principles are being clarified, and a glossary is being clarified. Please check it out if you want to open. Well, for now, it's open-GitOps, github.org/documents, and all of that is there. And we're at an RC2 with a planned full release of the principles before KubeCon. That's our next milestone. So in short, it's this. It's everything for your system that you at least want to have managed by GitOps, and ideally everything required for disaster recovery is described declaratively. Not only your core Kubernetes objects, which already should be ideally described declaratively, or at least expressed declaratively somehow, but everything else required for the running of your system and your applications. So that's really the first principle, is that you can do that. And there are different tools that are added to be able to do that. So for example, as Martin said, Helm does not, part of its scope excludes a declarative version of itself or its own commands, because it is primarily a client with an SDK underneath for other tools to use. one of the things that Flux does is it allows you to declare your Helm releases and your Helm repos and other things like that declaratively. And I'll show you that in a second. So that's the second principle, or sorry, the first principle. The second is that it's versioned, and that these are stored as immutable. Those declarations are stored as immutable versions with a complete version history for auditing purposes. It doesn't have to be Git. It could be any version control or version. It can be any versioning system that fulfills those criteria. It could be S3 compatible storage buckets, for example, as long as they're versioned. Even with Git, if you don't configure Git correctly or take care, you may not satisfy the criteria for the underlying principles for GitOps. So it's really important to understand generally what you're doing, but in short, picking some tools that help you do this well will at least get you on your way. The third principle is that those changes that you make within that you version for everything you want to happen in your cluster can be automatically applied to the system by itself. So this differentiates it from CI systems where generally you only have someone asked earlier about Jenkins or other tools like this. I'll get into more depth, but just as a very quick example of why these principles matter, with CI systems or traditional CI/CD systems, generally those changes on your target system or your actual state of your running system are only triggered by changes that you yourself make in your CI runs. So that does not, for example, help when something changes in your Kubernetes cluster or on your system that had nothing to do with you. You know, like something broke, or there was a bad actor, or someone thought they were working on dev, but they actually pushed something to prod, you know, et cetera. That won't actually change until your next CI run. Whereas the fourth principle currently the fourth principle in GitOps is that you've got software agents running on your system, constantly monitoring or periodically ultimately polling at whatever set interval you want, your configurations, what you said is your desired state of your system, all the things that were just discussed. And it says, hey, does your system match this? Including meta state and other rules around your system that can include things like progressive delivery and so on. You can still have things like that. That must all be defined in your desired state. Basically anything needed so that if your cluster goes down, it can be reproduced in such a way as it would be indistinguishable from what you had in the first place, or if you scale up, et cetera, or if something goes haywire. So the idea is that these software agents are constantly trying to ensure the correctness of your actual state, and they're letting you know when something's wrong. So that's it. That's that. Let's see. So I'm going to move a little quickly because I know we have 15 minutes. Am I right about that?
Yeah, we have 15 more minutes.
Okay, great. So I'm going to fly over this, and I may or may not do this demo. I might just point you to a gist for the demo and show you how it works, because that might be the best for time. But ultimately, really just a tiny underscoring of certain pieces that Martin mentioned about Helm scope. I'm going to talk briefly say how Flux's scope is different than that, and how it fits into the design of Helm 3 and what other apps are supposed to do and how we're supposed to take it from there. And then I'm going to, I'm at least going to talk about moving Helm releases from CI to Flux CD. I think that answers some of the questions folks asked earlier about the different runs and why we recommend separating CI from CD, or decoupling those at least. So I could mention the architecture, but I won't spend too long on that because I understand that you've all seen other Flux presentations before mostly. Just give a couple of notes about this. I could do the demo, and then thanks, and Q&A. So Can you all hear me okay? Am I talking too quickly or am I pretty good?
Yeah, we can hear you. It would be cool if you could show a demo. People love a demo.
I can definitely do a demo. I'm prepared to do it.
Okay.
So I
cool.
can fly through other things and prioritize the demo. That's better. Okay. So in short, when Martin mentioned certain things that were in scope and out of scope for Helm, I won't go over this again. You can see this and sort of, remember what Martin had said. But yes, what he said about structuring multiple environments, Helm doesn't really do that. It gives you tools to be able to do that, like we had talked about, but it doesn't actually do that for you. That's where other tools have often come in, such as Helm file or a bash or a make file or things like that. Many people do this as part of their CI systems or however they want to, helper tools for their developers. Helm also doesn't manage it doesn't include any control loop or retry logic by default. Basically so Helm is now a client and SDK only, and that's the most important point to walk away with for the Helm scope piece, because that was the design for Helm 3. As Martin mentioned, the server side component was removed, and so the Helm SDK was there for the Helm's client to consume, and also to allow other tools to fill in these gaps or fill in these use cases that are now defined to be outside of the scope of Helm. So Flux is the only CAD tool that I'm aware of that purely uses Helm's SDK. It doesn't do any shelling out to a binary. It doesn't fork Helm to do it. It doesn't just use Helm Template. And it's also a good citizen of the Helm community by not maintaining its own fork and instead contributing changes upstream that are likely to be supported.
Scott, to just come in on that, I think the operator SDK does the same.
Oh, great. Oh, yes.
Yep.
The operator SDK, yes.
Yeah.
Thank you. Yeah, I probably should maybe group that in with the CD tooling. We'll look at it later, but thank you. Yeah.
But it also uses the SDK and doesn't do any forks, etc. Yeah.
Right. Yeah. And there are other good tools. Thank you, Martin. And there are other good tools that do use the Helm SDK purely. I was mentioning only CD tools, but maybe the operator SDK falls into that, and I just need to look into it. Thank you. Yes, the SDK is widely used, and it's a very important part of the Helm ecosystem. So the important point to note here is because Flux uses Helm's SDK, you can still use the Helm client as normal to check the status of Flux delivered Helm releases. So there were a few questions about that earlier. I said I would cover some of that. That's just a little intro to it, and you'll see how that works better. The main point is that why you should care is that you can still use Helm as, in a GitOps world, you're perhaps not interacting with your system on a normal basis directly. You're doing it through your version control system only. However, for platform teams during incident management, and there are some other use cases where you need to pause GitOps automated reconciliation and get in there and fix whatever's going on, find out and fix whatever's going on. And you can use Helm tools to do that because there are still Helm releases through Flux. So in short, Flux is a pull for CD system. Yes, you can have push webhooks to help speed that up if you decide to have longer time in between your polls. But if you're using any kind of a tool that doesn't also use the pull model, then you're not really following the GitOps principles, and if you do configure Flux to do that, you're missing one of the major values of Flux. So so what Martin said about Flux scope. Helm's not meant for cluster resource management, but Flux is. And so, yeah, that's one of the values is disaster recovery. So you can just kind of skim over this, just the headers while I'm speaking about this for a second. But essentially, the Helm client doesn't handle timeouts, right? Like I mentioned. So that's another thing that the Flux controller does. It handles intelligent responses. The Flux Helm controller gives intelligent responses to various conditions that are going on in your cluster, and helps to handle what needs to happen when certain applications fail. If there's a wait time, etc. You don't have to build that into your charts and do a lot of workarounds to make that happen in order to use Helm any longer if you use a tool like this to do that. The other thing about what Martin said about CRDs, one of the reasons the Helm client doesn't manage CRDs is because upgrading CRDs with, whether it's with mutating webhooks or however people generally do update their CRDs, it can be a very long-running task depending on how many custom resource instances you have of those CRDs. So, that's why a client is not well suited for that. And that's why that's one of the main reasons it was left out of the scope of Helm. It's not the only reason. One is that Helm is scoped to be namespaced and a CRD is cluster-wide. So you really want to make sure that you have some kind of tool that's focused on total system resource management if you want it to help you with things like updating custom resources and and that's one of the things that Flux can help with as well. So yeah.
Scott, I just want to jump in real quick. I want to apologize because I haven't been running the time very well. So I know it's really thrown off your presentation, and I know you wanted to get to a demo. But we have about 6 minutes, and I'm just wondering how we should do this, because I'm thinking, unfortunately, we're not going to have time for the demo. So I apologize for that.
Maybe I should actually just jump right into that now. I was going to skip right over the architecture piece because it's already been described, but I was really going to, you're right, I was going to mention a few of these other cool things and show some cute slides, but I think we can make these available for you all afterwards. And instead, all right, how about this? Instead, I will escape this and go to this demo.
Awesome.
I think we can do it. Let's give it a shot. Thanks, Josh. Okay, so I'm going to go ahead and share my entire desktop now, or I'll share. I'll share my terminal. That'll probably be better, and I'll send you all this link to the hands-on. It's also in the slides that I'm sharing. That will help show you what's going on. So, okay, cool. Thank you, Stacy. Yeah. So really, this is really just going to give you a quick overview of what you need to do. I'm not going to go ahead and reinstall Flux and Kind, but that's all you really need for this. Excuse me. What I will do is I'll give you the version of those because I had done this right before, and you can see they are updated now. The other thing we need to do is we need to make we need to set a personal access token, and I'm just going to do this in a really safe way. I'm going to, let's see, on a demo, I'm going to go ahead and, oops. Sorry, I just need to open my one password again. I think we got this. Let's see, time me.
You got this. We'll give you a couple extra minutes.
Yeah, here we go. I'm going to copy the bootstrap. I'm going to paste it here. So you don't really, I don't have to worry about you all hacking me. And let's just do a, check characters. Okay, cool. That's the right number of characters, so we're good. Okay, so then, what I probably could have done is save us 20 seconds by creating a cluster. And ultimately what I'm going to do is.
You already have a cluster there, Scott.
Oh. Sorry about that. Let's do that again. As you can see, I mean, hopefully most of you are using Kind. It's just such a helpful tool for both your CI and your local development if you want to use them for that. Okay, and then okay. All right, maybe I'll just share my entire screen because then you can flip-flop back and forth. And please tell me if, or sorry, I won't have to flip back and forth. Please tell me if it's too crazy to read. I'll just share the whole desktop now. Okay, this should only take another 20 seconds. Can you see it? Okay.
Yep.
Okay, great. So what I'm going to do now is I'm literally going to just use this Flux Bootstrap command. And to be clear, I'm not anywhere special in my my working directory is nowhere special. I'm literally running a Bootstrap command, which adds, I'll tell you what this does. Oh, sorry. This is hilarious. Since I did the read S, I need to export it. Okay, so what it's doing is it's creating a repository right now based on the name of the repository I just gave it. It's saying that the branch is main, and it's giving me a path to create inside of the repository where all of the manifests for running Flux will be housed. So at this point, it's only just basically from this point on, GitOps is being used for Flux itself. So the nice thing about that is that, you know, if your cluster were to go down, okay, so this is already there. If your cluster were to go down, GitOps can help you bring you right back up. So that's really fantastic. Okay, so I'm gonna go to, I'm gonna go here, and I'm going to, remove that. I'm going to go ahead and start a fresh clone here. Okay, we're almost there. Josh, if we run a minute over, is that okay?
It is. I was
Yes.
just going to mention that.
Okay.
Yeah. Yeah.
Okay, great. So now I'll just show you the tree real quick. And what it does is it just adds a directory called Flux System, and that stands for the Flux System namespace, and it shows different components that are for the GitOps toolkit. The specific manifests for actually syncing them. Sorry, and I'll show you what this one looks like. The rest is just there's too many manifests, but you can take a look at it in the repo. So this is really just one of the CRDs that Flux, one of the Flux controllers use, the Flux source controller. It actually sets the information about the Git repository it just created. And the Flux customize controller is what is used to apply the plain YAML in this case, which is, you know, we're not really doing anything special with customize here. It's just that customize is part of the kube control command. It's built in, and so customize has kube control apply essentially baked right into it. So we kind of got a freebie with that one. So that's why we use that to, it basically says every 10 minutes, it's going to take all the manifests that are in your cluster, and it's going to go ahead and our Flux customize, controller is going to apply those to the cluster. So essentially, we're applying everything needed to run Flux by Flux because we bootstrapped. So if we do get the namespace, we'll see we now have a Flux system namespace. And if we do, well, yeah. Oops, oh, right, you can't, whatever. It's okay. Well, you can see that Flux is running. Let's see. Okay, get pods.
So Scott, just reiterate again. What are you trying to show here?
I'm trying to show right now that our Kubernetes cluster has bootstrapped and it's got all the Flux stuff running in it. So in short, it's quite simple. If you look at my little progress bar, I'm like mostly finished here. I'm kind of at the bottom. So this is just very, very, very simple. We have a way to like Flux commands to actually create a source. And one of the source, in this case, the source is a Helm repository. So with kind of like what you will do with Helm file or other types of tools where you specify a repository, a Git repository, so that you can then deploy your Helm chart. We do that through a CRD. So you can write this yourself. And if you see what I just, oops, my Git diff. Yeah, sorry. You'll see that we have this file. And if you take a look at it, it really is just the information needed to give our system, to let our system know how to pull in metadata from the Helm repository. So I'm also going to help create a Helm release. Very quick, and very similarly, this is what the Helm release looks like. You don't need to use these commands. Oops, excuse me. You don't need to use these commands to do it. They're just helper commands, and they really help folks kind of make sure to get on the right track. And there are also tools to help validate these as well. So ultimately, basically, it's like at this point you're doing GitOps. So now I'm just going to do a git add. Normally I wouldn't do a git add dot, but we know it's we'll do a git dev staged, right? Okay, cool. So then I'm going to do a git commit. Oops. And then you know, do the thing for expedience. Now I git push. Now this pushes it to my repo now that exists, which is here. Okay, almost there. So it had pushed these here, and since we already told Flux to look inside of this directory with our initial Git repository, it's already going to sync them now. It won't sync them yet, I'm sure, because sorry, give me a second here.
Hey, Scott, very sorry to cut you off. I'm extremely sorry. We're kind of running short on time.
Yeah.
I would love it if you could kind of share, some takeaway from the demo, just for the audience to kind of, understand exactly, what the takeaway is. And, we'll be sharing out in the slides and what we can share out for the audience to take away as well.
Yeah, exactly. So basically, like the ultimate takeaway is that, well, that's the demo. But now what's happening is we've got pod info running on our cluster, and it's because we have used Flux to create a GitHub source. We've used the Flux CLI tool to create a not a chart museum, but a Helm repo source. And we have deployed the Helm controller and told the Helm controller, hey, we have a Helm release that we want to release here. And so now the controllers are running on their own from this point on to take the manifests from our repository and automatically deploy them. What I would, well, I'll stop sharing, but what I would have liked to show you is that it automatically does it. You can also poke the Helm controller with a just a reconciling function, which is exactly what happens if you set up webhooks to make this faster. For example, if you do pushes in between your intervals that you set, say you set it to check every 1 minute. or every 2 minutes or something like that. If you push a change to your GitHub or whatever your source is, you can set up webhooks to trigger that and pull that in automatically. But what happens is if that pod gets destroyed or if something else happens, your Flux system will automatically say, oh, this is what we wanted to happen. You don't have to wait for a next CI run. You don't have to wait for notifications on failure. Your Flux system your GitOps system will automatically restore your cluster to the state that you declared, including, in this case, Helm releases.
That's awesome. And I think that's really the beauty of the GitOps toolkit. You just tries to match that state. Yeah, that's great. So Scott, thank you so much. I know we're running a few minutes over. I'm extremely sorry that we couldn't find enough time to wrap up your talk.
Okay.
But this was
I
great.
hope that helped a little.
No, it definitely did. And thank you so much, Scott. And thank you, Martin, for the amazing talk we had today. And audience, thank you so much for joining us. I know we ran a few minutes, but thank you so much for joining us. There is a link to our next event and the Cloud Native Meetup in the chat. So please feel free to sign up, and we hope to see you all again. So thank you so much.
Thank you. Quick question, Josh. Can we save the Q&A so we can get back to folks later? Okay. Thanks.
We can. Josh, can we still use the Q&A box? I think we can use the Q&A box. So if anyone has to roll off, we'll be answering your questions. So feel free to drop them and we'll get back to you.
Great.
Thank you, everyone.
Thanks, Martin.
I see we have about 3 questions here. The first one is about, I believe, the garbage collection in Flux.
Yeah, I'm reading that now. That's interesting. I'm actually not sure the answer to that. It should, my understanding is it should work, but I will say this. When using the best way to install Flux, when you're installing it yourself, rather than say using like an operator hub or whatever, which is a great way to install it too. If you're on OpenShift, for example, but if you're installing this yourself, Flux Bootstrap is really the best way, because with the Terraform provider to install Flux, as well as if there were a Helm chart, right, to install Flux, there are specific things that you still need to do, specific manual steps you need to do. I believe the finalizer should work. So if that's not, Anish, if you could please find an issue for that, or open one on the github.com flux cd / flux2 repo. And even if you're struggling to find that or know how to do that, please get on the CNCF Slack #Flux channel, and we can help look for that together.
Scott, I'll be sending you the questions. We've captured all of that. So
okay.
I was having technical issues on my side.
Got it.
Well, Scott, I'm looking forward to meeting you at KubeCon. I will definitely be tracking you down. When are you going to get there?
Yeah, I'm getting there. I'm flying out Sunday morning from New York, and I'll be arriving, late morning in LA on Sunday.
You're going to be an early bird.
I will.
It's going to be a long week for sure. Okay, Samia, thank you. Martin, thank you. Great talk, everybody. Stacy, thank you for making it happen. And we couldn't do it without you. And Scott and Martin, we're honored to have you. You guys have made significant contributions. And it's definitely great to have you join us. And we'll be having you come back hopefully sooner than later. Okay, everybody.
Thank you very much.
Safe travels.
Thanks so much. Bye.
Thanks again, Josh.
Thank you so much.
Bye, Samia. Bye, Martin.